y to negative 10, we have negative y to negative 10, and negative y to negative 10. Perfect. So let's take a look. Y to negative 10, if you remember, this is just a condensed form of this fraction, and there is nothing else we need to do. So again, as I mentioned, do not assume that this is a negative number. By looking at the power and seeing, oh, the power is negative, the answer would be negative. No, no, it could be, but that's not the reason. Okay, now on this one, I don't have enough room there, so I'm gonna move here. This is 1 over negative y to the 10th power. I apply the same rule, but this time on negative y. I bring negative y down and I change the negative 10 to positive 10. But now, negative 1 to an even power is positive. So this changes into y to the 10th power. Because negative 1 to the 10th is positive. Y to the 10th, copy the base and multiply the exponents. The last one, the negative in front of y has nothing to do with the power. That has to stay. So this is y. This is negative 1 over y to the 10th. It happens that these two are the same, but this is a totally different story. Is this okay? So this was 16. Any questions, anybody? Okay, moving on to 17. Let's look at 17 and see if 17, this is exactly the same situation. If you want us to work on it, please say so. Do we want to see 17? Okay, 18. Yeah, I want to work on 18. In 18, you see 12 divided by, I'm sorry, I wrote y. It's w. That is the same thing. Well, when I have y to negative 4, this is the same with 1 over y to the 4th power. But what if the negative power is at the exponent, is the exponent of a quantity found in the denominator? So this was in the numerator, it went and ended up in the denominator. But now this is in the denominator. It will have to, obviously, by the same rule, end up in the numerator. So this will be 12y to the 4th. So again, if the negative power is in the numerator like this one is in the numerator. It's not in the denominator. So it will go to the denominator. But if the power, if the exponent is a negative on a quantity, or the exponential notation is found in the denominator and it also has a negative exponent, it goes back to the top.
What if there was a number in front of the y? So let's say 12 over 6y to the negative 4th power.
Yeah, so I simplify and it's 2.
Okay.
If you want to consider it in parentheses, it's a different story.
Okay.
You want to consider it in parentheses?
Yes, please.
Yeah, sure. I don't want to change the problem. So now I will change the problem. So if we have, let's say, 12 divided by 6y to negative 4, the answer is the same, 6y to the 4th power. The whole thing is, the whole thing has power negative 4, so it has to, the whole thing goes to the top. And now we have 12 times 6 to the 4th times y to the 4th. And I'm considering multiplying these two. So 12 times 6 to the 4th. So 12 times 6 to the 4th power. And I get 15,552 y to the 4th. So there is no change Whatever quantity has a negative exponent and it is found in the denominator, the whole thing goes to the top. Alone or not alone, it doesn't matter. That the rule is the same. Is this okay?
Yes, thank you for doing that.
Of course. Very good. Let's continue. Okay, so these are the same. Exactly what Sarah asked. What if there is a number here or there? But please look carefully and say yay or nay.
Yes, please.
All of them?
Let's just do B.
Okay, so in B 2m to negative 7, let's do all of them now. Negative 7 and negative 2m to negative 7. Good, let's do all of them. So obviously here, everything is incorporated, so I have 1 over 2 to the m, everything to the 7th power. And now I have to write 1 over 2 to the 7th times m to the 7th. And 2 to the 6th is 64, so 128, I think. Correct me if I'm wrong. So 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64, and 2 to the 7th is 128. That was the first one. Not in the same order, but the first one I have here. The second one, 2m to negative 7, you cannot touch. You cannot touch the 2. The 2 cannot go anywhere. It does not have a negative power. You cannot move it anywhere. The last one is the same with the first one because negative 2m to negative 7 is 1 over 2, negative 2 to the negative 2m to the 7th power. And now negative to the 7th power is negative, and I can put it in front. 2 to the 7th is the same thing, 128. And m to the 7th is m to the 7th. So the situation is different because the number is negative. Not the power, but the number inside. That is the one that dictates, that is the one that changes the whole thing.
Is there a reason why throwing the entire problem over 1, it changes the sign of the exponent back to a positive?
That's the rule.
Logical explanation?
That is the rule. So this is the rule for negative exponents. A to negative n is 1 over a to the nth power. This is a notation, a condensed notation of this, and that's carved in stone. So a fraction can be condensedly presented as the base to a negative exponent. It's a different way of writing a fraction. Is this okay? Okay, back to our problems here. Let's look at 20. Okay, let's talk about 20. So 3 over x squared to negative 2. I want to talk about this. This is an important situation. I'll come back to the problem in a second. So a divided by b, let's say, to the nth power, it's a to the nth power over b to the nth power. But if the power is negative, the answer is flipped. So first is b over a to the nth power, and then you apply the rule again. So please understand the difference between these two. Here, the power is positive, so I cannot touch anything, I cannot change anything. But in the second example, we have a fraction that is raised to a negative exponent. So I should have written the intermediate step 1 over. Instead, I skip that step and I flip the fraction, because when I divide by a fraction, I have to flip it anyway. So this is a better option. If the power is positive, you cannot change anything. But if the power is negative, all you have to do is just flip the fraction and then apply the same procedure. So therefore, in this situation, all I have to do is write x squared over 3 to the positive power. I flipped the fraction and I changed the negative to positive. So I copy the base and multiply the exponents, and 3 squared will be 9. This is a very important exercise. Any questions on this problem? So this was 20. Okay, can anyone give us the answer to 21 before we continue?
7 times 2x to the third.
So 7 over 2, very good, times x to the third, excellent. So that is correct. We only had x to negative 3 in the denominator, we had to bring it to the top. And that's it. Good. Yes, we should work on this problem. So negative 3b, and this is 22. Negative 3b divided by a to the third, and everything to negative 3. What do you think we should do first? What will be the first step here? Yes, flip the fraction first. Don't touch anything. Just flip the fraction, indeed. So it's a to the third over 3b and everything to the third power. Do not apply a negative power before you flip. It's not the best way. Will you get the same answer? Yes, of course. But I don't recommend it. And now, careful. You have to raise the negative 1 to the third power, to the third power, 3 to the third power, and b to the third power. This is always easier than dealing with negative. So always flip first. Very good. Thank you. So negative 1 to the third is negative. A to the third, copy the base. What happens with the exponents? Yes, 9, we multiply them. 3 to the third, do not choose and pick and choose. You have to raise everything to the third power. 3 to the third power is 27. And b to the third is simply b to the third. And this is the final answer. Any questions on this? Okay, perfect. Let's see 23. 23. I keep clicking on 22. Okay. Is it something that we want to work on? So please look carefully.
Yes.
Yes, very good. Let's take a look at 23. And 23 has negative 13, m to the fifth, n to the eighth, over 5m to negative 2 times n to power 0. Look here. All variables are non-zero. Very important. Good. So this is what I recommend on this problem. First, take care of the sign and the numbers. There is nothing you have to do here. There is negative, there is 13 divided by 5. Then, copy the base and subtract the exponents. 5 minus negative 2. What do we get? 5 minus negative 2.
7.
Very good. Now we have to analyze n to 0. They are telling us there is no variable that is 0. How much will this be?
1.
Indeed. Don't get into that trap. This is 1. So all you have to do is copy n to the 8th. And that's it. Nothing else. Any questions on this problem, on 23? Any questions on 23? Okay, moving on. Let's take a look at 24. Yes, no, maybe.
Yes.
Yes, very good. So let's take a look. This is my page 4. And this is negative t to the 5th power raised to negative 5. And this is problem 24. Good. This is what I would do with this. Again, take care of the negative power and have 1 over negative t to the 5th and to the 5th power. That would be the first step. Now I have to raise everything to the 5th power. So negative 1 to the 5th power is negative. Copy the base, multiply the exponents. Positive over negative is negative. 1 over t to the 25th. And this is it. Any questions? Any questions?
Now,
It-
if they wanted no negative in the denominator, you would just move that to the numerator.
Yes. If the power were negative, yes.
Gotcha.
If a quantity in the denominator has a negative power, I would move it first to the numerator, yes. If it were a fraction, then I would flip it. Yes. Good. Moving on. Good. 25. It's the same type. It doesn't matter if you say yes, we'll work on it. But this time we cannot flip. So you have to raise 3 to the 2nd power, and then let's do this one. So 25. So 3m to negative 4, everything squared. In this case, you cannot flip anything at this point. So we only have to write 9, copy the base, multiply the exponents, and now you will change it into this. You cannot move 9 anywhere. 9 does not have a negative exponent. Good. Okay, look at this one and say yes or no.
Yes, please.
Very good. So let's look at 26. In 26, we have 36a to the 4th, b to negative 8, everything divided by 9, a to negative 2, b to negative 6, and they have to say this. This is crucial, because if any of the a or b is 0, then the whole thing collapses completely. It does not exist. Or it's indeterminate, etc., etc. There are other situations. Of course, I take care of the numbers first, and I get 4. Of course, I copy a and I subtract 4 minus negative 2, which is 6. Of course, I copy b and I subtract. Always from the top power, I subtract the bottom power. Negative 8 minus 6 is negative 2. I cannot touch 4. I cannot touch a to the 6th, but I have to change b to negative 2. So this is 4a to the 6th over b squared. Remember, we have no rules when the bases are not the same. Don't try anything here. This is carved in stone. It's done, and no one can change it. We only have exponential rules when we have the same bases. Okay? This is it. Good. Good. Let's look at 27. Yes or no? Hearing nothing, I'll move on. Yes, no? Okay. 28. Okay, in order to simplify this, be very careful. Let's simplify it together. So that's 28. We have 64 to the third over 4 squared. You cannot use an exponential rule because the bases are not the same. So that will not be possible.